Hello. Today we're going to take a look at terminating, recurring, and rounding decimals. Basically, what we're really going to do is learn how to convert a fraction into a decimal. Now, when you convert a fraction into a decimal, you'll get these interesting situations where the decimal places may come to a point where it becomes recurring, as in it'll just keep going and it'll going and it won't stop. And with recurring decimals, there's certain notation that we use, which I'll show you how that looks. You can also, I guess, when a recurring decimal also happens, sometimes it's better just to round it to a specific decimal place. And I'll show you how to round decimals as well. Thankfully, as well, and you'll know this if you've worked with decimals and fractions with a little bit already, is that sometimes fractions can also not be recurring. So, for example, 1/2, most of you would know the decimal representation of that is 0.5. That's a terminating decimal because after 0.5, there's no real numbers afterwards. It's 0.5 of what it is. But whereas something like 1/3, and I'll show you over here, is 0.333, and it just keeps going and going and going, and we call that recurring decimal. Okay, so that's the difference between recurring and terminating. I'm going to show you a few examples just to show you how this looks with some instructions on the right here. So you can take a look at this, and this might help you if you want to pause the video, if you want to use that eventually. But I'll show you how to do each of these questions and show the little intricacies you should be looking for, or the little steps that you should be doing in order to get the answer. Okay, so the first question says, convert the following fractions to a decimal. First thing you need to know is that when you write a fraction down, you need to know what this actually represents. Okay, um, of course, we know through experience and being able to learn this earlier on that this is the numerator, this is the denominator, and the middle thing is called the vinculum. Some of you may not remember that from year 7, but that's what it's called. Okay, what's essentially happening with a fraction is that you're actually doing a division that hasn't happened yet. Okay, so what I mean by that is 1/4 is the same thing as 1 divided by 4. It's actually the same thing. And I want you to know, pay attention to the division sign. You may have not seen this before, but the division sign is basically a representation of a fraction with the numerator as a dot at the top, the denominator with a dot at the bottom, and the vinculum right here. So essentially speaking, 1/4 or 1/4 is equal to 1 divided by 4. It's the same thing. So to convert a fraction to a decimal, you actually just do the manual division or the short division that you're going to do with those two numbers in mind and understand which number is the divisor and which number is the dividend. Here, because it's 1 divided by 4, this is the divisor. Okay, the number on the right of a division is the divisor. The divisor goes outside of the division. So when you're writing it down, 1 divided by 4, the 1 is here and the 4 is outside because the outside number, this, is the divisor. Okay, some of you should see a problem already. The problem is I can't, 4 doesn't go into 1 at all. So how do we actually get into the point where we're getting into a decimal number? Well, what you can actually do is you can make decimals by just adding zeros. You can read here, make 0 by adding zeros. Here's how you do it. We're going to go 1.00. We're just going to do that. Okay, we can put as many zeros as we want, but we'll start with 1. Maybe we'll start with 1 and we'll keep adding zeros as we see fit. Okay, 1 is equal to 1.0 is equal to 1.00. So adding zeros doesn't actually change the question. It just makes the question possible for us to convert to a decimal. Remember when we do decimal division, the decimal lines up. So here's the decimal. So here 4 goes into 1 0 times with a remainder of 1. So this becomes 4 goes into 10 how many times? Twice with a remainder of 2. I don't have any more digits, so I just add more zeros. Okay. Remainder of 2. So 4 goes into 20 5 times. And the answer is 1/4 is equal to 0.25. Some of you already know this, so you can look at this answer as a way to verify that this process actually works. Let's do 7/8 and see what happens. So B 7/8 is equal to 7 divided by 8, and then you can write it down as short division here. So 8 is the divisor, so it goes on the outside, 7 is the dividend. 8 doesn't go into 7, so I need to add a 0 here. 8 goes into 70. Remember, this 7 is because there's a remainder of 7 after 8 doesn't go into 7. So 8 goes into 70 8 times with a remainder, add more zeros, you can see here. It's a remainder of 6. So 8 goes into 6 7 times, the remainder of 4. 8 goes into 40 5 times, and no remainder. So the answer is 7/8 is equal to 0.875. That's how you convert a fraction to a decimal. Now, this is straightforward here because these are what we call terminating decimals. You can see it stops. We don't need to do any more division from here. Sometimes we get recurring decimals, and you'll have to learn how to write the notation for these. I'll show you, for example, 2/3, which is equal to 2 divided by 3, which we can do the short division with the 3 as a divisor, 2 on the outside, or inside, sorry, 2 on the inside. Okay, 3 doesn't go into 2, so there's a remainder of 2. 3 goes in 26 times with a remainder of 2. 6 times, remainder of 2. Okay, can you see what's happening here? It will just keep going. There's nothing we can do. It will just keep going until infinity. There's nothing we could do until the end of time if you kept going, if you wanted to. Of course, you wouldn't. So what we need to do is express the following. This is the question. Express the following as recurring decimals. This is how you do it, okay? 2/3, I'll just write it here actually, is equal to 0.6. Now, I could write 6 again, 6 again, 6 again, 6 again until the end. And sometimes you might just want to write dot, dot, dot to imply that the 6 keeps going. But what we're going to do is we're going to write a dot on the top. By writing the dot on top of the 6, we are telling the person reading our solutions that the answer is 0.6, with that 6 continuing to recur over and over and over again. So if you need to pause the video to write down the notation, this is what it looks like, just like this one. Okay, 0.666 recurring is how you write it. Let's try B. Question B is a mixed fraction, so hopefully you're familiar now to convert this into an improper fraction. So it's 3 times 7 plus 5. The 3, 7, 21 plus 5 is 26, and then the denominator stays the same, 26/7. And so once again, this is division, so it's 26 divided by 7. 7 is divisor, so 7 goes on the outside, 26 goes on the inside. 7 goes into 2 none times, or 0 times, with the remainder of 2. 7 goes into 26 3 times, I believe, with a remainder of 5 here. So 7 goes into 50 7 times with a remainder of 1. 7 goes into 10 once with a remainder of 3. Keep going. You notice we can keep going, but we haven't seen a pattern yet. Oh, I have to put the decimal. We haven't seen a pattern yet, so we do have to keep going until we see a pattern. 7 goes into 30 4 times with a remainder of 2. 7 goes into 20 twice with a remainder of 6. Yes, we do have to keep going. You'll see why. We'll see what happens. 7 goes into 60 8 times with a remainder of 4. 7 goes into 40 5 times with a remainder of 5. Okay. Now this is what I want you to see. Some of you are going, you can't possibly get me to write all this. But yes, you do have to actually write all this to keep going, because what happens is sometimes recurring decimals happen the way that we had it here, where the pattern becomes very clear straight away, that the 6 is just going to keep showing up over and over and over and over again. In this case, the pattern hasn't finished until now. Now, 7 goes into 50 7 times. Now, why is this important? Well, if you remember, we've already done this step. 7 goes into 57 times. So, and then we've done all of this, and what's resulted is all of these numbers afterwards. What's going to happen is that same pattern is going to keep happening with this 7 right here starting, and then a whole bunch of the same numbers, 1, 4, 2, 8, 5 again, and then it's going to keep recurring. This is also a recurring decimal, except the pattern is, except this time the pattern is going to be 3.71428. And now this is actually the pattern. So what would happen, I'm just going to write it down so you can see, it will just keep doing this. That's the pattern. That's what's recurring over and over and over again. It just took this many iterations before we found this pattern. Now, instead of writing this to the very end, how you can write that this is recurring, instead of drawing the dot at the top of the number, which we did for the 0.6, because there was only one number that was recurring, if multiple numbers are recurring in the same sequence and the same pattern, you draw a line at the top here. So we now know it's 3.714285 recurring, with the 714285 being the thing that keeps going. Okay, that's what you do for these sort of situations where the recurring decimal is actually multiple decimals instead of just one. Okay, let's learn how to round again. Some of you should already know this. In this case, take a look at this question here. It's 15.35729, and we want to round it 3 decimal places. We need to look for the 3 decimal places. So we got 1, 2, 3, and then the next number, the number after that, is the one that tells us whether we should round up or down. So 5 or up, 5 or greater, I guess, greater, you round up. 4 or lesser, you round down. Okay, that's how you round. In this case, I see a 2, which means that I'm rounding this number down on this number and this decimal, because it's 3 decimal places. This is the thing that either changes or stays the same. So this is rounding at the 3 decimal places, 15.35, and because we're rounding down, this number does not change, and we finish. This is 3 decimal places. If you want to make sure, 1, 2, 3. Okay, 3 decimal places. Now let's look at the second one. 4 decimal places for 4.86195082. I count to 4, so we have 1, 2, 3, 4. This number is the one that tells me whether I should round up or down. It's 5 or greater, so this number has to be rounded up to with 4 decimal places in mind. So this becomes 4.861. And now here's the tricky part. 9 needs to go up. Now, if 9 goes up to 10, which means that this becomes 0, but this number changes. So we had to add that, because it's 10, we had to add that extra place value in. So it's 4.8620. Okay, that's how you round numbers. You have to check, if I'm rounding to 4 decimal places, do I have 4 decimal places at the end? If I'm rounding to 3 decimal places, do I have 3 decimal places at the end? Okay, make sure you check that. Okay, look at this one. 3/7 is actually a recurring decimal, I believe, but it says, instead of recurring or showing it as a recurring decimal, it says correct to 2 decimal places. So we need to do this the right way. 3 divided by 7. We did this before, by the way. This is nothing new. 7 goes into 3 none times, so put the 0 on top. 3 remainder. 7 goes into 30 is 4 times with a remainder of 2. 7 goes into 20 twice with a remainder of 6. 7 goes into 60. Now, 7 goes into 60, 8 times. Okay, remainder of 4. But here's the thing. It wants us to round to 2 decimal places. Okay? Now, to round to 2 decimal places, I actually need to have 3 decimal places here first before I figure out how to round. So 0.428, we need to round to 2 decimal places. I'm looking at 2 decimal places, 1, 2. This third number tells me whether I should go up or down. It is 5 or greater, so it's greater than 5, or 5 or greater. So it has to be rounded up. So the number becomes 0.4, and this is the number that goes up or down. So this number goes up, so it's 0.43. I've rounded it to 2 decimal places. Hopefully this helps. Give it a go. It's a little bit tricky sometimes with the rounding, but just remember the rule here, and you need to pause the video, write this down as your rule. 5 or greater, you go up. 4 or lesser, you go down, but that's with the digit after the specified amount of digits you need to do for rounding, okay? Hopefully this helps.